continuities we encountered?
Jump.
Yes? Jump, removable. Very good. And infinity. Very good. Awesome. And we have them here. Right here. Infinite, removable, and jump. Very good. Definition of continuity at a point. This is extremely important. You're going to have this type of problem on our first test 2 weeks from today, definitely, for sure. Definition of continuity at a point. What should I write? Anyone, please?
Equals the limit, or the limit equals the function value.
So you mean the limit of f of x as x approaches a from the left?
Yes.
Must equal the limit of f of x as x approaches a from the right, and must equal f of a. Indeed. So the limit from the left, the limit from the right, and the function value at that point have to exist, and they have to be equal. Very good. What about here? Anyone?
Equals 0.
Thank you very much. Okay, any questions for me, please? Is there anything you would like to start with? Anything? Anything that you encountered from the previous lessons or from Pearson?
Could we do a problem where it gives you 0 over 0 again?
Yes. So here's an example. So here's a limit. We are given the limit of a function. What is the first thing we need to do? Unless it's an
Evaluate the function.
Yes. Assess what's happening here first. There are some exceptions, but this is not one of them. Okay, so can anyone tell us what is the preliminary assessment for this limit? Preliminary assessment.
Uncheck a factor x squared minus 4.
Preliminary assessment. I need to put something here as the preliminary assessment before I decide what to do next.
Infinity over infinity?
Well, 4 minus 4 cannot be infinity.
Okay, so you're plugging in 2 for x, right?
That's what we always did. That is our first step. We said we have to plug it in. From the very beginning, or maybe it's in the previous lesson, we have to plug it right here. Plug it in. This is step number 1. Before you do anything, you have to plug it in. Of course. What can I plug in? Whatever this is. This is the first step. And then after the initial assessment, I will decide how to proceed. So then, what is the initial assessment?
0 over 0.
That's it. 0 over 0. So I know that there is hope. Good. And somebody already told us what we need to do. Okay, what is that again? Anyone?
I can't.
Difference of squares for x squared minus 4.
Very good. How do I do that?
X plus 2, x minus 2.
Excellent. And remember, we always have to write x not equal to before I simplify. There is no need to write it now because this says x approaches 2. X does not equal 2, so it's redundant to write it again. This is already fulfilled. And of course, the whole purpose was to do this. And I'm going to jump over all this and continue here. So the limit as x approaches 2 is from what now, after the simplification?
X plus 2.
Of course. Now this is a polynomial. How do I find the limit of a polynomial?
Let's plug in 2 for
That's it. And the answer is
4.
4. This doesn't always happen. Hope doesn't necessarily mean that it's going to happen. But in this case, it did. So the limit of this function exists because it's one single number and I can name it. If I say to you it's a number but I cannot name it, then I'll say forget it. There is no limit. I have to be able to name it, and we did name it. Again, what does this mean? It means that when x approaches 2, this function, the function values are not equal to. This is not what the limit is saying. The function values get closer and closer to 4. That's all it means. The operator says, when x approaches 2, what does this function do? Well, this function gets closer and closer to 4 when x approaches 2. Perfect. Anything else? Other questions for me? And I'm on page 2.
Can we do one more for approaches infinity?
Yes. Do you have one for us?
Can we just do the one that was on homework just because I have
Yes, anything. Yes, anything, any problem, anytime, anything.
limit x approaches infinity, and then it's 5x squared plus 5x plus 2 over 10x squared plus x plus 1.
Good. So this is a specific situation that we already discussed, or we'll do it again. So we factor out the degree at the top, which happens to be 2. We factor out the degree at the denominator, which happens to be 2. And we go through the same steps, identical steps, that we looked at last time in problem 35. Exactly the same. So that's why I'm begging my students to redo those problems, because the more you practice, the better off you are. Okay, so the initial assessment. I have to start with the initial assessment to see what, and then decide what to do. Because if the answer is 3, I'm done. I don't have to do anything. There is no decision I have to make. So what will be the initial assessment?
Well, if you plug in infinity for x, you would get infinity over infinity.
Exactly, because these are too small. These are too small when it comes to infinity. So then 5 times infinity squared over 10 times infinity squared, because the rest are too small. They're adding up more, but they're too small. Infinity over infinity. So again, there is hope. But when it's infinity over infinity like this, I cannot use the procedure I used before with 0 over 0. This is a specific type, 0 over 0. In this case, I had to factor. And I was able to get it very quickly, get the answer very quickly. But here is a different type of factoring. I have to factor out the degree at the top and the degree in the denominator. Again, they may be different. You are not factoring one because the other one is 2. No, we factor out the degree at the top, whatever it is, and the degree in the denominator, whatever it is. So now, since I see 3 terms, I need 3 terms. Since I see 3 terms, I need 3 terms. Such that this times this will give us this. This times the middle term will give us 5x. This times 2 will give us 2. This times whatever will give us 2. And the same thing in the denominator. Can anyone help?
Put a top.
5 over x.
Good. 5.
5 over x.
Excellent. Plus.
2 over x squared.
Excellent. Let's take a moment and check. This times this? Yes. This times this, you simplify an x, you get 5x. Here, you simplify the x squared and you get 2. Perfect. What about the denominator?
10 plus 1 over x plus 1 over x squared.
That's it. Of course, that's what I'm going to do. Do I have to write that x not equals 0? No. because x approaches infinity. It's so far away from 0, I cannot even see it. You can write it if you want, because otherwise we can't simplify, but we're talking about infinity. It's so far away from 0. So I'm allowed to simplify. Now I have to think. And what am I thinking is, where is this going? Where is this going? Where is this going? And where is this going? Because this is 5. Nobody cares where x is going. The limit of 5 is 5. The limit of 10 is 10. But the limit of 5 over x, the limit of 2 over x squared, the limit of 1 over x, and the limit of 1 over x squared when x approaches infinity, what will these be?
They're getting closer and closer to 0.
Excellent. Absolutely. How do we know that? From here. From here. So this 0, this 0. So then, what is the limit?
5 over 10.
Exactly. Because
Simplifies to 1 over 2.
exactly, these are all gone. So the limit of 5 over 10 is indeed 5 over 10, which simplifies to 1/2. And remember what this means. As x approaches infinity, the function values get closer and closer, closer and closer, closer and closer to 1/2, 1/2, 1/2, 1/2, which means that is a horizontal asymptote at infinity. It will be at a negative infinity as well. But in some situations, we have to check. In this case, it will be both, because it's a rational function. Good. Other questions for me? Anything else? Anything else? Okay, perfect. Perfect questions. Let's continue with 1.4. And now I can talk about the title of this chapter. It's a fancy word. Differentiation. Differentiation. What does it mean? Okay. So calculus deals with motion, with change, if you want better. Deals with change. So let's say I have a function, and I would like to know at this point, not the average rate of change, but the instantaneous rate of change. I want to buy a stock, and for, I don't know, Apple, let's say. And I want to know if at this point the rate of change of the price with respect to time is positive or negative. I want to know if here